Initiating recording device. Would you insist? That's what you wanted? Okay, fine. All right, today's topic. Today's Tuesday, the 22nd. Today's topic is more on differentiation rules. Product rule, quotient rule. We didn't finish the quotient rule, right? Yeah. So, all right, let's start that up again. So, how far did we get? Let's see.
You get that for work?
What? Where?
Word?
Yeah. No, just have to go through all these stupid clicks. No, you don't.
Oh, okay.
Yeah.
Maybe on the computer.
They're all open technically. We're not using them. All right. So, what do we say? Well, if h of x is f of x divided by g of x, the question is, what's h prime, right? So we got this far. We applied the definition of derivative to this function, and we said that h prime is the limit as h goes to 0. We did this yesterday, right? Of, well, you tell me, f of x plus h over g of x plus h minus f of x over g of x over h. Good. Alrighty. That's f of x. That's the general rule, the definition of the derivative. Limit as h goes to 0 of f of x plus h minus f of x over h, whatever your f of x is. So then we said, okay, we're brilliant and we know how to subtract stuff, so limit as h goes to 0. Let's see, we multiply top and bottom by g of x, f of x plus h over g of x plus h, minus, and we multiply top and bottom by g of x plus h, get that common denominator, right? So f of x times g of x plus h over g of x times g of x plus h. Whoops. Fabulous. And don't forget it's over h. Actually, we didn't do that. What did we do with the h? Instead of dividing by h, we multiply by the reciprocal of h. That's h over 1, so what multiplied by the reciprocal was 1 over h, right? And then, did we get this? How far did we get with this? Yeah. All right, well, then we put it all together in with one denominator. The limit as h goes to 0 of this ginormous mass. Remember, we tried to add 0. Did we get that far? We're so good at adding 0. Got to do it whenever we can. Right, so the denominator is this and times that, right? Okay, now remember what we want. We want low d high minus high d low. Well, this is low. How do you get d high? What's missing? Ethan. Right, but I can't just do minus f of x. I could add f of x and subtract it, right? That's okay. But that doesn't help because I need a g in there. Yeah? Right, so I'm going to subtract f of x, g of x. Okay? And we're going to add it too. Right, okay. Does everyone see why? Because now what's your favorite f word? Factor. The g, and you got f prime. But here you factor what? F, and you don't have g prime. That's not g prime. What's wrong with it? Yeah, Ethan. Doesn't anyone else have a hand? Yes, Ethan? So it's a science, yeah, okay. So let's do that. So we get the limit as h goes to 0 of take out the g, and you're left with f of x plus h minus f of x over h. So low d high, that's what we want. All right, minus, let's see, now, we took out the f of x, right? So there's f of x times g of x minus g of x plus h all over h. All right, so that's, sorry, plus. I just took out the f here. So it's left this g minus, that's the common factor. I mean, yeah, that's all. But look, what's nice about it, This is definitely f prime, but this,
So what about on the other side?
well,
Couldn't it be a that sound? That's on the other side.
I did there.
Not the one that's written on the bottom.
Well, because it's a factor, it's still there.
Still there.
No, it was this times this is that. I said, what's your favorite F word? Oh my goodness.
Oh,
Get with the program.
all right.
Yeah. It's 6 letters, careful.
Oh,
I know.
Wait, why don't you put it all over?
Well, because I'm making the point that I have low, D high, minus, do I have minus, high, D low?
Plug in the negative one so you can rearrange it.
Right, I didn't rearrange it yet, but I'm going. You don't even have to. Isn't this just the opposite of G prime in the limit? So we know what it is. Instead of writing plus this times this, I'm going to say minus this times G prime in the limit. All right, so we can just do the limit right now. Okay, so the limit as h, well, let's just do it. What is it? As h goes to 0, this becomes what? F prime. As h goes to 0, this becomes not G prime. Negative G prime. This is backwards. And in the limit, this becomes what? As h goes to 0? G squared. Okay, so it's like we wanted. It's low, D high, minus high, D low, over low, low. Amazing how that works. Now, last year they just sort of like memorized that rule. How do you memorize that rule without the Snow White? Huh? I don't get it. You guys don't know the Snow White song? Without knowing why, and just memorizing without understanding, I don't know how the heck you remember that rule, but anyway, without a song. You gotta have YouTube. That's what YouTube's for. What? Kind of rhymes. Okay. Yeah. Well, that's why they make a song out of it, right? Okay, so that's good. Is there any other way to deal with that? Well, this looks a little odd.
Oh, do we have to do that whole thing on that?
Well, yes and no. Good question. Here's another way to deal with it.
Do the low D high.
Well, hang on. Do you really have to use the quotient rule? Look, let's say f of x, not f, it was h, right? Let's say h of x is still f over g, right? But isn't that f times something?
Yes.
G to the negative 1, right?
Yeah.
Now, don't get confused. I don't mean the functional inverse, the inverse function of g. I mean actually 1 over g. Okay, I know that's confusing there, but there you go. Usually when you write that with a function, you mean the inverse function, right? I'm not meaning that. Maybe, you know what, to make it more obvious, I should write it this way, perhaps.
Product.
And so you can use the product rule instead. So do you need the quotient rule?
No, you don't.
You don't. Let me write it this way so it's not confusing. Okay, then that's obviously a power, right?
Test it out.
Let's do it. Let's do the product rule on this and see that you, in fact, get the exact same rule.
Yeah.
It's amazing. I'm getting so excited at 7 o'clock in the morning, or 8 o'clock in the morning. So, what's the product rule? First times the derivative of the second. Now, how the heck do you take the derivative of u to the negative 1? Negative 1 times g to the negative 2 times g prime. Don't forget the chain rule. Now, technically, this invokes the chain rule, which we're not really talking about until Friday, so this is illegal. I can't do this yet, but we will. But you've seen the chain rule. Does anyone know that you need the derivative of the inside function? When you take the derivative of a function, which is made up of 2 functions. The inner function is whatever the hell g is, and the outer function is like 1 over x, right? You have to take the derivative of the outer function, negative 1 u to the negative 2, u to the negative 1, negative 1 u to the negative 2, but then times du. We'll find out why that is on Friday. We'll talk. Okay? So that first times the derivative of the second plus second times the derivative of the first. Now this is the second. And the derivative of the first is just f prime, whatever f is. I don't know what f is. Any f, any g, right? As long as it's differentiable, and the product is too. Okay, well, that does not look a lot like, wait, like that, does it?
Not yet.
Not yet is right, okay. Because look, Why does it always go back to the top? There's a g squared on the bottom, right? Don't we have a g squared on the bottom? Huh. Alright, let me rewrite this a little bit. It's a negative 1 times f, so negative f times g prime over g squared, right? I just put this thing in the denominator, that's all. And a negative fg, right? Okay. And then what's this? Well, this is f prime in the numerator and g in the denominator. Well, you know how to add stuff, namely fractions. How do you add fractions? Need a common denominator. What's missing over here? G. Multiply top bottom by g and you get g squared on the bottom. Ooh, that's nice. That's so nice. So you get, let's see, what the heck do you get? I'm going to write it this way. G of x, f prime of x over the common denominator, right? Once you have a common denominator, just add them. Well, is that what we wanted? Well, it's backwards. It's low d high minus high d low. Yeah, it's the same thing. So do you really need the quotient rule? Not really. Sometimes it's convenient. Sometimes it's a pain. So it's up to you whether you want to use the product rule instead. All right? Okay. That way you only need to know one rule, right? Why memorize more than you've got to memorize? So let's play with this. Let's say, everyone got that? Okay? Did I go too fast there? PDF is online after school. All right, so what if y is x squared plus 1 times x cubed, sorry, x, what do I want? Cubed, yeah, plus 3. What's y prime? You're going to use the product rule. Well, you're also going to be using the power rule somewhere, right? There's a number of rules mixed in. Okay, so what's y prime? It's going to be, how do you do it? Product rule. First times the derivative of the second. What would that be? 3x squared. Then, followed by plus the second times the derivative of the first, which is 2x. Okay, let's simplify that. Now, that's an answer. If you wanted to, like, know the slope of the tangent line at x equals 1, boom, plug it in, you're done. That's usable. But let's clean it up a little bit. How about if I distribute the 3x squared, I'm going to get 3x to the fourth. Yeah, you could use it. Right? So I just distributed, right? Did I do that right? Yeah. And then 2x times this is a 2x to the fourth plus 6x. And so the final answer in standard form would be 3x to the fourth. No, I have 2 of them, so 5. You guys are better at this than I am. What the heck? Okay, plus 3x squared. I can't write. 5x to the fourth plus 3x squared plus 6x. Now, is that the only way you could have gotten that answer? No, you could have... No, not the quotient rule. Huh? No, not the formula first, and then use the sum of the derivative of the sum of two functions is the sum of the derivative of those functions, right? Are you going to get the same thing is the point. You probably won't get this, but you can probably get this. So let's try that again. What if y is, same thing, x squared plus 1 times x cubed plus 3. What's y prime without using the product rule? Let's just sort of confirm the product rule. So first I'm going to follow it out. Right? First, outer, inner, last. Double distribution. Distribute this twice, distribute this twice. Okay, so that's really x to the fifth plus x cubed plus 3x squared plus 3 in standard form. So now what's y prime? Using the product rule and the sum of two functions. What? Let's see, does that look familiar? 5, 3, 6. 5, 3, 6. You have little faith. At fourth, second, first. Fourth, second, first. Looks good to me. Amazing. Phenomenal cosmic powers. No, you missed the illusion that I was making. Phenomenal cosmic powers. You know that movie? Phenomenal cosmic powers. Anybody who has living space. Aladdin, yes, Aladdin. That would be the genie. That would be Robin Williams. But anyway. Okay, what if y is x squared minus 1 over x squared plus 1? What's y prime? Using the quotient rule. Alright, so what do? Low d high is, what is it? 2x. Followed by high d low is 2x over low. Which means that thing squared, that's all. Now that, again, that's usable in a problem where you need a derivative. You're done, right? But let's clean it up a little bit. 2x to the third plus 2x, quantity minus what? So what's left in the numerator when you subtract? It's not 0, is it? Right, 2x minus a negative 2x is 2x plus 2x is 4x. The 2x cubes will cancel, and you're left with this. But again, is that the only way you could have done this problem? That's the answer. Well, that's an answer too. You could have left it like that. You could have left it like that. But this is just a lot easier to use. I wouldn't simplify more than that. Nah, leave it at that. But is that the only way you could have taken the derivative of this? No, remember you could also use the product rule, so let's do that. What if y is x squared minus 1 times x squared plus 1 to the negative 1? And just use the product rule and see if you get the same thing. Okay, so y prime is, how do you do product rule? First times the derivative of the second. Now what's the second's derivative? Don't forget up here. What goes up here? Negative 2 times 2x. Yeah, don't forget that part. People forget this part. Don't forget that part. Derivative of u to the negative 1 is negative 1 u to the negative 2 du. Okay. So first times the derivative of the second, then what? Plus the second times the derivative of the first, which is 2x. Right? Now, that's an answer, but remember how you clean it up. This is a denominator, this is a denominator. I'm going to multiply negative 2x times this. Okay, so let's see. Negative 2x times this is negative 3, no, not 3. Negative 2x cubed, give me a pen. 2x cubed, right? I'm taking a negative 1 and a 2x times this, a negative 1 and a 2x times this, so what? Plus 2x, right? Over x squared plus 1 squared, okay? Plus, this is a numerator and this is a denominator, 2x over x squared plus 1. Okay, well, that's an answer, but what can you do with it? I'm trying to see if I can get the same, I'm getting the same answer as this, okay? So I'm going to need a common denominator, right? So common denominator would be x squared plus 1 squared. So multiply top and bottom by x squared plus 1. So I get negative 2x cubed plus 2x, that stuff, plus x minus 1 times 2x, which is 2x cubed plus 2x over x squared plus 1 squared. Okay, does that look familiar? What's in the numerator now? It's 4x again. Isn't that what we said? Well, you messed up, but there it is. Same thing, right? That's what we got with the quotient rule. That's what we got with the product rule and the chain rule and the power rule and all the rules. The million rules here. Technically, it's harder to do it this way, but it's the same thing because it involves a lot more rules. But you know the quotient rule and the chain rule, and we're going to practice that up. All right, just for fun, let's check with Hal. Hal hasn't been around lately. Why haven't I been using Hal a lot this week? Because these are all algebraic techniques you should be able to do by hand. realize half the AP exam, there is no calculator to fall back on. Now, you always have a calculator on my tests, but if you can solve something algebraically, I want to see it done that way. Okay, don't use the calculator if you don't need it. You have to make the decision if you're going to use it or not, right? On the AP, it's not like that. Well, actually, it is like that. On the part ones that involves that they allow the graphing calculator, there are a lot of questions you don't need the graphing calculator for. They want you to make that decision there too. Okay? There's something like 17 multiple choice questions in part 1A in about, I think, 51 minutes, I think they give you. They give you more time in those. Yeah, they give you more time on those questions. They usually give you 2 minutes per question on the non-calculator multiple choice. They give you 3 minutes per question on the calculator section with the calculator because you have to decide if you need it or not. And then you have to use it. That might take a little more time setting up, typing in, and blah, 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 right? So now you guys are hopefully proficient with the calculator. That should not take that long. Unfortunately, I found out the hard way, you're not proficient with the calculator. Yeah, because a lot of people got stuck on the tests with that x plus h to the fifth, right? What's so tough about x plus h to the fifth? You could FOIL it out, can't you? If you had to. You could use the rule that I gave you on the paper, that's sigma, and the factorials. You could do the binomial expansion theorem the way they did in class. Or you could just ask Hal. Look, ask Hal. I saw this in extra help, right? Those people who were here in extra help. Let's see, where do I have Hal? I have Hal over here. I haven't seen Hal in a while. Forgot where he is. Okay, come on, Hal. Hal, wake up. Okay. Okay, so like, for example, what if I wanted how to do x plus h to the fifth? Here's alpha h. Where's alpha h? Is that h? I can't see it from here. All right, to the fifth. All right, so I hit enter, and Hal tells me the astounding result. That doesn't help. But see the algebra key? F2, which function do you need? Expand that. Just cut and paste. And voila. 1, 5, 10, 10. What am I? 5, 1. Remember Pascal's triangle? It's in there. You can do the whole freaking problem this way. Minus x to the fifth. Divided by alpha h. Where'd the h go? I always lose the h. There it is. And now just plug in limit as h goes to 0. What do you got? In fact, I think we figured it out in class. What was it now? It was F3 limit. Where are you, limit? There you are. Of that, comma, h, alpha h, comma, at 0. Going to 0, right? And guess what? You get amazing. All right, so Hal can do all the algebra because Hal is a computer algebra system. It's all built in there. So that's your fallback plan if you need it. But realize you should be able to do this algebra by hand, and you will on the AP. There won't be a calculator for stuff like this. Okay. That's why I didn't make a big deal about using the calculator for this stuff. So, now, what were we doing? Well, we were going to do the derivative on Hal. How do you do that? Well, let's see. Let's clear this. Let's clear that. I'm going to do this derivative. Well, the original one. This one. I'm going to do this derivative on Hal and see if Hal agrees with that result. Where's the derivative key? Well, yeah, or second 8. And now I want to type this in, right? So numerator in parentheses, quantity x squared minus 1, close the parentheses for the numerator, divided by numerator in parentheses, denominator in parentheses, right? So open x squared plus 1 close the parentheses for the denominator, close the parentheses for the derivative. Well, no, wrong. You have to say what you're differentiating with respect to x. Is that what we got? Wow, Hal's pretty quick at this, huh? Okay, what was the other question we've had? Let's see, this one, right? And that was our answer? Let's see what Hal thinks about that. Second eighth of this mess, right? Open parentheses, x squared plus 1, close parentheses, open parentheses, x cubed plus 3, close the product, close the d, no, damn it, I did it again, comma x, close the d. Well, yes, it's how felt like factoring the x out, but there it is. That's how like simplest form is factored form, and that's all there is to that. Okay, was that terrible? That was not terrible. Okay, let's try here's a question from the homework page, something like this. Well, I'm going to give you this one, all right? What if y equals x plus 2 over x? Can you get the tangent line at x equals 1? Find the tangent line at x equals 1. Well, you need the derivative, don't you? So y prime is negative 2 over x squared. Now, how did you get that? How do you differentiate this? Ethan?
Switch it to the form 2x to the negative 1.
Okay, like we did before, right? Then it's just a power rule. You don't have to do the quotient rule, right? You could have done the quotient rule. But, so let's see, we get a negative 2x to the negative 2, don't we? So it's 1 minus 2 over x squared. You want to do the quotient rule? Right, fine. If you're differentiating this, what do you get? Low, d high, minus high, d low. That's sort of silly to do all that work. Over low, low. Is that the same thing? This is 0, that's negative 2. Same thing? That's x squared, right? You could do the quotient rule, but why? That's so much work just to do that. Okay. So what are we going to do with y and y prime? What do we need both? We need y of 1, and we need y prime of 1, right? Y of 1 is, plug in 1 over here. It was 1 plus 2 over 1 is 3. And it's 1 minus 2 over 1 is negative 1. Okay, so what's the tangent line? Y minus 3 equals negative 1 times x minus 1. x1 is given. y1 we figured out. M we figured out. By the way, what's the normal line? Y minus 3 equals what? 1. The negative reciprocal of this times x minus 1. Okay. Can you, now that's called point slope form, because any point and the slope define the line. Can you give it to me in slope intercept form? Can you get y alone?
Why is that 1?
Y is what? What? I said this is the tangent line, this is the normal line.
Oh.
These are two different lines.
I thought you had to put it in like the slope.
That's what I'm going to do next.
Oh.
You're ahead of me. Okay. All right, so I got two lines. I originally asked for the tangent. That's confusing, I know. I do that. Okay, so can you get into y equals mx plus b form, the slope intercept form? What do you do? Jeremy? So y minus 3 equals negative x plus 1. Y equals negative x plus 4. Okay. And then do the same thing for this guy. Y minus 3 equals x minus 1. And y equals x minus 1 plus 2. Right? Did I do that right? Add 3? Yeah. Okay, what if we graph all this stuff? What are you going to see? If we graph the function, x plus 2 over x, and we graph these lines, you're going to see the tangent and the normal at the point 1, 3, aren't you? Let's see. Wake up. So I'm going to clear this, I'm going to clear this. I'm going to go to... Yeah, I'm just going to confirm that it looks like a tangent and the normal and all that stuff. All right, so it's x... what the heck was it? It was plus 2x, right? X plus 2 over x is the curve, and the tangent line was at negative x plus 4, and the normal line was x plus 2. Okay, so x plus 2. Enter. And let's do a zoom 4 so it's a square window so things look perpendicular when they are, for example. At the point 1, 3, we get, hopefully, a tangent line. There it is. And the normal line, there it is. Ta-da! Is at the point 1, 3. Well, hit trace. What the hell's trace? F3, isn't it? And let's trace it to x equals 1. And there's the point of tangency. And they all have the same point, 1, 3 for the curve. Down arrow on the tangent line, y2, 1, 3. Down arrow on the normal line, y3, 1, 3. They have the same point, right, in common. You have, well, that if you start with a zoom 4, it's automatic. If not, you got to play with your window settings. Okay, and I'm going to leave it at that for now. That's why I start with zoom 4. Start with zooms 4 and then just take multiples of x min, x max, y min, y max, and you're fine. Okay, bye-bye.